upon a time in the age of discovery and exploration, two men raced to the South Pole. This guy here, Edmundson, and this guy here, Scott. Now, Edmundson, he is pretty smart about how he went about it. He went to the Eskimos and worked out how they do things. He lived with them for a while. He worked out their rate of work. He adopted their dress style. He learnt how to ride sleds. He also thought about the exploration. So, his experience in the ice knew that storms could come in at any time. So he put multiple food sources in his path so that he would have success. He put flags to direct him to that just in case. He took 4 thermometers in case one broke. Our friend Scott over here, which, I grew up believing was a bit of a hero and certainly brave and full of courage, went there, but he bought donkeys and he bought sleds, motorised sleds, which neither had been proven in the snow and both failed. He didn't have lots of stores of food. He didn't have extra thermometers. And the end result is that Edmundson was the first there and came back and lived a long life. And Scott and his companions didn't make it. Hi, my name's Mike Wilson. I work with the Central Coast Industry Connect. We're here to assist you in your projects and developing your business to the next level in manufacturing. I've been doing this over 30 years now, and the intention of today is to give you an overview, a brief run through. I'll go as quick as I can and won't take too much of your time. But I encourage you to use and utilize companies or non-for-profit places like the Central Coast Industry Connect to assist you and to learn from other people's mistakes. The thing is that factory design is a process. It doesn't take lots of smarts. It doesn't take extra skills. And the thing is, you can learn from the mistakes of other people. So factory design is a process. Innovation is a process. Being strategic is a process. And change is a process. None of them need to be scary. And the difference between a good and great design is the number of questions asked. Now, there are 7 stages or steps to a factory design. First, we want to get the team right. Second, it's about the money. So understanding where the value lies. What's the essence? What's the thing that makes a difference? What is it that we need to do to ensure that you maximize profits? Then the numbers and the schedule. These are when you're laying out your factory, how are you going to run it? So the schedule determines when you do changeovers. If you do lots of changeovers, it's going to be a different design to something that requires you could run for 24 hours. So the changeovers don't matter so much. And if you've got people, then people are ultimately the most flexible, but there are considerations in that as well. And then we move on to flow diagrams where we map it out. And the thing I like about flow diagrams is they change the context of how you're looking at it. So in a flow diagram, you're looking at the process and not the machines. There seems to be a fixation in manufacturing and people, when they're doing projects, to look at the machines first and start from there. And we'll talk more about how that 65% of the project is determined in the first 5%, and most people miss that stage. And then we go to the layout, which everyone's pretty comfortable with. Everyone's moved furniture around at home, and so you get a sense of how that works. But there are ways to do it optimally, and there are places to leave contingency and space. And then we've got cost and scope. So the scope determines the cost. And we'll run through how you pull that together. And usually what happens is people build up this wish list, and then you go through and say, well, actually, I can't afford that bottom number. And so you take line items out. And then you got the timeline. The timeline tells you when to panic, and that's a good thing to know. So once again, 65% is determined in the 5%, and most people jump straight into the layout. Machines are part of the process. They aren't the process. There's a whole bunch of things that happen around those machines for the machines to run optimally. And ideally, that's what we're going for. Now, we want to be simple and we want to be consistent. And in fact, the secret to good manufacturing is consistency. So if I could just go over to the whiteboard now, and you'll see that if you've got a consistent machine, so this is your machine or your process, and it's consistent. If you have a consistent going into a consistent, then you'll get a consistent out. And that's the goal. So what we want is a process all the way down the stream where we're gaining consistency. Now, if you're dealing with things like fruit, for example, or something like that, where you're dealing with nature and you can get inconsistency, what we want to start doing is we want to start streaming it as we go through the process. So we bring it into a consistency as much as we can. I'll go back now. So, and the other one is that we want to stay relevant. We want to stay relevant to person and task. There's so much noise that goes around in a factory, and I'll talk to this as we go through. It's really important to maintain momentum when you're going through the project. So there's so much, people see walls and they get stuck. And with momentum, you can kind of pass through things. So one of the mantras or one of the things that I really talk to is great is good optimized. And so if we've got something good right now, let's move on. Let's just keep moving with good. And then with time and relevance, because we might work something up that's not relevant to the final design because we don't know what the final design is until we get there. And so it's this whole idea of continuous improvement. And we do this in the project. But we really want to set the architecture up of the original design so that we can keep adding to it. And so, Warren Buffett said, make a decision and make it work. To stay looping and keep your mind full of things that you're working on can be really consuming and actually means that you miss opportunity. Because we're not designing a factory for today, we're designing a factory for the future. We always want to build in a bit of contingency and room for growth. And for the bigger projects, we're looking at 5 years. For a lot of the smaller players, who most of the people here will be, you're looking for growth for the next 1 to 2 to 3 years, and then you'll be looking at something else. The idea is to move on quickly through the don't knows and not sures. It's almost like dancing. You just want to move around them. You don't want to get fixated or stuck on them, because quite often I've found over 30 whatever years of doing this is that those things you can get stuck on actually aren't relevant in the future anyway. And give away as many problems as you can. Now, I wasn't really going to talk too much about this, but there's a guy called Mihai Csikszentmihalyi, and what he spoke to is the capacity of our conscious minds to only handle 7 things at a time. So if you're handling more than 7 things at a time and you take on a couple more, it creates stress and you start dropping balls and forgetting stuff. But more importantly, if we are designing, we want to be in the designer mindset. And so Einstein said that inspiration is the thing that comes in between the thoughts and not from the thoughts themselves. So stress compresses our thoughts and fills us up. So there's no room for inspiration. This is why a lot of our good ideas come in the shower, when we're taking the dog for a walk, or just relaxing. It's because there's room for that unconscious to feed through. If our conscious mind is so full, then we aren't open to new ideas that potentially could be a game changer or a step change. So design has legacy in it generally, and there's a wonderful story, and it's about a roast lamb. And so I think it was Bryce Courtney, but I'm not sure, was talking to his wife, and his wife cut the end off the roast lamb, put it in the oven to cook it. And he goes, "Why did you cut the end off the roast lamb?" "I don't know. My mum always did it." "Okay, why did your mum do it?" "Well, I don't know." So she phoned up the mum. "Well, it's because my mum did it." "Okay, cool. Why did your mum do it?" "Give grandma a ring." "Well, because the pan was too small." And quite often we find in factories there's all this legacy. So what we want to do is we want to leave the legacy as much as possible, and we want to create something new. And so start with the end in mind. And that's the first lighthouse. So where do you want to get to? So don't look at building up from where you are, look at where you want to get to, and then build that up. So it's almost like castles in the sky type stuff. The other one is essence. And, Steve Jobs, with the iPhone, he wanted to create the best product possible and then do it for as cheap as possible. And so therefore the essence was the best product possible and then doing it. And so you ask different questions. The difference between a great design and a good design is the number of relevant questions asked. And so coming back to the essence. And so there's a sculpture back in the 1600s, and he said that simplicity is complexity resolved. And so if you imagine you go into this factory and you've got a big ball of rubber bands, we don't know what color we're looking for until we understand the essence. And when we do, we pick apart all those rubber bands, we lay them out, and we might have four or five things of essence that will determine that we get a really good result at the end, and then build out for those. It really does work. The other one is design around the operators, the person doing the work. It seems such a simple concept, but if we make it so that we get it right for the operator, they will be efficient, and that means that everybody wins. Get it right for the operator, get it right for everyone. And focus on the what, not the how. Generally, people who are entrepreneurs or engineers are probably the worst, excuse me. They tend to be stuck in the how, and that's a whole bunch of stuff to drag along, but we don't know if what it does is it limits the possibility, the what. And so we want to ask questions to the limit of possibility. So another quote, I'll just run this off. And it was Arthur C. Clarke who said this. He goes, "You don't know where possibility sits until you go into the impossible, and then we want to come back." And all this is just asking questions. That's all. And the thing is, you don't have to know how to do it yet. We just want to determine what first. So the 7 steps of factory design. Team. Like Edmondson, we want to hire and leverage experience. We want to take this what, we lay it out, and then we want to put as much known around it as we can. We want to take as many people, we want to get as many people on the team that have done what we want to do so that we don't have to be the expert. And the thing is that, I find a lot of people do it themselves, but when you break down a project costs, it's 10%. So if we just consider that, so you've got 10%, which is the general, and that could be higher, depends on, but 10 to 15 maximum. Sometimes some of the big companies have 20% because they're like a safety person in every corner. But generally for the smaller projects, you will rock in around 7 to 10% if you keep it light. And that's not a lot of money when you consider that determines how you spend the 90%. And then this determines what your operation costs are. So like to save $10 or $20 on a project manager at this level is really short-sighted when you consider the bigger gains and the bigger implications of not getting it right. So Einstein said spend 95% on the question and 5% on the problem. And it's amazing. When you put a problem in front of people, they just jump in with their answers. And so in order to get context, it's about actually understanding. So it's like that root cause analysis. What are we actually trying to resolve with this question instead of just asking questions? So really think about the question itself and then the answer comes. It's almost like magic, because ultimately we want to slice and dice the project as much as possible, because the more relevant questions asked, the more relevant and better the operation and the facility will be. And ultimately that's where we want to get to, is optimal. And one thing you do is you bring in experience. The money. Now this is funny. I went out to someone just the other day and they couldn't answer these questions, and yet they're making strategic decisions about their business. And I sometimes go to large companies and the general manager doesn't understand this. And to me, this is fundamental to manufacturing. COGS. So COGS basically are raw materials, labor, and overhead. Now, on the smaller operations, we're going to have, maybe labor is sitting at 60%, maybe raw materials at 20%, and overhead is 20%. Thing with overhead, that is a function of widgets out the door. So we're not going to focus on that, but we are going to look at this, because if this is my breakdown between raw materials and labor, then my focus is around reducing labor. And in fact, in a lot of the bigger operations, these numbers are different. So the raw materials is generally around 60%, and labour's 20%. And so I'll go in there and say, right, we want to reduce labour. It's like, well, yes, but this is actually more important. And the things when I started doing this back a long time ago, I'd walk into a room and it's designing rooms for 100 people. Now you've probably got 10. So if one person's away, you've just lost 10% of your workforce. So the whole labour conversation can be a bit distracting, especially when it's raw materials. And with automation, and we're at the precipice of change. And so raw materials will be 80%, 10%, 10%. And that's really the tension of manufacturing. In fact, ultimately talking about lights out and places like Amazon are doing that. So when you got 80, 10, 10, you're not really, to look at labour is a distraction. In fact, you're probably better off adding an extra person or whatever it is if it makes a difference on that, because then that becomes the focus and you ask questions to that. And that becomes the essence. And so when you're looking at a machine, yield becomes very, very important. Technology. Technology is good if someone can fix it and run it. Getting people who you will pay more for people who can do that. And is that beneficial? Like technology for technology's sake generally doesn't work. It costs you flexibility. People are more flexible than machines. Who's going to maintain it? And is it relevant to your business? I think if you look at the machine and what it's actually going to give you, and then look at if we automate it and what that's going to give you, and then who's going to maintain it, operate it, and what's the cost of it going wrong. And I see some places rush into technology only to find that they can't optimize it because they don't have the talent or the local support system to do it. And your local support system is paramount to your success. And we'll talk some more about that. So the numbers and schedule. This is where, for an engineer, it gets interesting because this determines the numbers that will determine success. So if we look at a schedule, for example, if you so you've got a start. So say we do a changeover, and then operation, and then wash down, and then changeover, operation, wash down, and that continues all the way down. Now, if that is 1 hour, then those numbers are absolutely critical. So say that's 30 minutes, and that's 30 minutes. Then, if you're doing 100 units a minute down that line, our average is only 50. But if we have that over 21 hours and it's 30-30, you see we're getting up around the 90 something. And so if we have, say, 1 hour production runs, and sometimes you have to do that because if you're dealing with Coles and Woolworths, they want 75% of your shelf life. So this is where it becomes really important what your customers actually require from you and the shelf life of your product, which is why it's good to get people in your team to look at the shelf life, and it plays right down through the whole stream of things. But if we for example have 1 hour, then what we want to do is buy machines that get that down to 5, or we change how we bring things into it to shorten that, and we might look at how we do the wash down, the wipe down. You can have conveyors with cleaners on them, all that kind of stuff. So there's a whole bunch of stuff we can do to reduce that. But that, once again, will drive the questions you ask. And this is what it's all about, is around the questions you ask, the relevance of those questions to the operation and how you want to run the factory. The numbers. So you might have a machine, for example, that runs at you might have a machine that runs at, say, 100 units a minute, like we said, and so let's say that's that machine there, and then we've got a machine downstream that runs at 60, and then we've got a machine upstream that runs at 120, and then we've got the most expensive machine, which is running at say, I don't know, 150. And so if I was to look at these machines, and this is the most expensive machine, I'd be questioning this one for a start. Like, what is the cost of that to get the most out of that? And they call this a bow tie, and I'll talk about this in a sec, but essentially what you do is ideally what you'd have is you'd have like 100 there, 100 there, and say this is a critical machine, the most expensive. And so in this machine here, we've got, say, I don't know, 80 and then 120. And so it's called the bow tie. So what you do is you push the product into that machine and then relieve it out. And the other thing too between machines is want some contingency. So say this is a packing machine. What we want to do is have this machine, and packing machines are notorious for breaking down and getting cardboard stuck or whatever it is if it's not stored properly. And so we might say every jam is 2 minutes, for example, and so we'd have 3 minutes accumulation. Because what we want to do is we're balancing a whole line. If you have individual machines with no accumulation or no way of keeping them running and no way of drawing back the accumulation so the accumulation is there for you, then you're going to run into problems. But I'm probably getting too complicated and too far into it, and I do apologise. I'm an engineer, I can't help it. You're going to hear people talking about OEE. OEE is the big boys talk to it. I don't know if it's that relevant, but if we actually have a look at what OEE is, so you've got availability, and that's sort of stoppages, and so that's labour. Now, if we go back to our numbers, it all comes back to numbers. No emotion, just numbers. So we get back to the, say, 60-20-20, which is raw materials, labour, and overhead. So the raw materials are the crucial thing. So if we go back to we talk to labour, we're not overly concerned because it's only the 20%. And performance, if you're running, potentially you could run at 110 and you're running at 90, but it's consistent. And more is better than fast. It's all about the widgets out the door. It's not how fast you're running the machine. It seems such a simple concept, but I see so many people making that mistake where they think to run it fast is the operation or is the goal. And it's not. The goal is to get the widgets out the door because it's to make money. In fact, talking about that, this guy wrote a book. It's called The Goal, and it sold like 10 million copies. And to me, it was obvious. We're in business to make money. But to people on the shop floor, it can be about efficiency. It could be about stock build-up. It could be about quality. Ultimately, all of those things are good, but the objective is to make money. And so when we have a look at quality, so quality is key. So first-time quality is yield. And once again, that's our 60%. So we really want to focus on that. Availability, if we're having lots of stoppages and it starts costing raw materials, then it's more expensive, but otherwise it's just labour. Now, for the smaller operations, this probably isn't such a big thing because it's more around labour and you've got more flexibility and you're not going to have the same stoppages that some of these big lines have. So relevance. So in communication, when we're talking to people on the line about their success, because winners win and nobody likes to be on a losing team. So if we have got a losing team, that can drag everyone down, even the people who are doing really well. But if we communicate to them their success and their winning, and then we measure them by it, then it really starts highlighting where the issues are. And it's the old Drucker principle. You can only manage what you measure. So in this example here, it's a game of soccer. I don't know very much about soccer, but let's look at the statistics, for example. So if the defender, for example, keeps the ball in the opposition half for 67% of the time, that increases the likelihood of the overall success of the team by 27%. And if he gets it if the forward can get 5 passes a quarter, that determines a 36% increase. And then Ronaldo's got a 6-to-1 conversion rate or strike rate. So you can see how everybody's got their own individual measurement of success. And look, I'm a big fan of providing people with incentive. If you're not getting results, what are your incentives? Flow diagrams. Love flow diagrams. In fact, I really start. So between, you've got the schedule, the number, the money, the value, flow diagrams, even though it's sequential like this, they go back over each other. And in fact, even when you get to the layout, you go back over it. It's, what you do in the flow diagram will change the numbers. What you do in the flow diagram will change the layout. What you do in the layout will change both. So the dynamic documents that we're traveling throughout the project with. So imagine we've got a big jar, and in that jar we've got, so we've got an empty jar, got a pile of rocks, pile of pebbles, pile of sand, and we've got some water. If I put the rocks in first, then the pebbles, then the sand, I'm going to be able to maximize that jar. But if I put the pebbles first, I won't get all the rocks in. And so in design, what we want to do is we want to focus on the rocks, position the rocks first, and then we build up around them with the pebbles. And so the rocks are money, of course, safety and quality, constant quality throughout. And this is coming back to that consistent into a consistent equals a consistent. And so pebbles might be your materials and people flows, for example, but you only talk to those once you've got the money right. And so if we go back to what I was saying before, the number of relevant questions determine the optimization of your project. And so we want to be talking at layers and questioning that layer as much as we can before we go into the next layer and then the next layer. And the more you can slice and dice and ask relevant questions of relevant people, the more optimal your design is going to be. And water ultimately is the communication. It's around everything. And it's absolutely critical. There are a few changes, back 30 years ago, there were no walls in process and you could walk in street shoes, and my things have changed. And one of the biggest changes is they started putting walls in factories. So you'd have high care, low care, etc., and packaging and all that. When you understand why they did it, it makes perfect sense. But the breakdown in communication is amazing. I remember once we were at this factory and I was actually walking around with the owner, and we went around into packing. There's a ready meals factory, and the guys had gone to break, and the spiral freezer was still running, and it was raining ready meals all over the floor. Quite a thing to see. So if I could say anything to this, just stay at the level you're at before going to the next layer. Plan to succeed. And they talk about contingency. Well, if that machine breaks, then I've got this other machine that I want to, but the thing is that if you've got a machine here and you put another line in the machine in case this one breaks down, that the floor area that you're taking up is $3,000 to $5,000 a square meter. That's very valuable real estate. And if we start looking at the machine, why is it breaking down? Let's repair that, let's fix that, and then use the space to make more money. So plan to succeed. Build in contingencies. So getting back to Edmondson, build contingencies around all the unknowns. Each one. If you're not sure, get someone on your team who is sure. And if you can't do that, what other contingencies can you wrap around it? And you might not use that contingency for that thing, but you will use the contingency. And the other thing is, let it be intuitive. If someone walks up to a line and it makes sense, they're relaxed. Relaxed people are more open-minded, expanded awareness, and they will make the line work much easier. The other thing too is that they will come to you and say, well, have you tried this? Because they feel comfortable with it. Intuitive is a light switch goes down for on and up. If you turn the volume up, it's that way. To turn it down, it's that way. And the thing is with the iPhone and Samsung or whatever, we've been trained or conditioned to think in a certain way. Use it. Why not? Everybody wins. And flexibility. Just build in some flexibility. Don't be too rigid, because you don't know what you don't know. You don't question what you think you know. And so we want flexibility to kind of give us a bit of room for movement in the future, a bit of wiggle room. So this is a flow diagram, baked beans, pretty simple. But so it's a process flow diagram. It's not a machine diagram. So we're looking at the process. So you can see, just draw a bunch of boxes, write on what it is. And then what, in some cases, for example, bean filling and sauce filling, for example, that might be one machine, but we split it to the process. One thing, and I spoke to this before, is that people get so used to seeing machine layouts or looking at machines. When you do this, it changes context. It makes everybody look at it differently. When people look at it differently, then they start asking different questions. Another strategy I do, and I'll get to this in the layout, but I'll just mention it now, is that I will purposely make a mistake. Just so, because people can generally tell you what they don't want rather than what they do want. And so if you build up a straw man or a design, and then they'll tear it apart viciously sometimes. And as long as you're not emotionally involved in that, that's great, because ultimately it's about we want a result. Einstein said that some people see an opportunity in every solution. Was it? Some people see a problem in every solution, and some see a solution in every problem. And so you got two groups of people. And so the people who come up with the design, we want them to be the solution people, but the problem people are just as important, because what they do is they tear down the sides and actually make the design more robust. Everybody has a place. Layout. Now, layouts are pretty good. Everybody can do them. Everybody thinks they can do them anyway. So where I like to start is layout with no walls. So can we go to the right one? So imagine this is our space that we've got. And if we were to draw the machine in, it would have to go something like that. What we want to do is get rid of the walls altogether and just draw our process like we live in whiteboard world, like it's perfect, like we've got all the money in the world and we've got no restrictions. And then when we bring this back into the room, we know what we're compromising. And we make a considered decision around that, because it's sometimes with these considered decisions that when we say, right, we've got to fit that in there, we realize what that's truly costing us, and then we can make a more informed decision about whether that's the right way to go or consider other options. And so that's why you compromise for reality, right? Because we haven't got unlimited budgets, but at least you know what the compromise is. Leave room for the future. You don't know where you're going to end up, but plan to succeed. And so don't try and ram everything in as tight as possible. Leave room at certain areas. I'm a big fan of 5S. So what 5S allows us to do is to say, right, this is dedicated for this is dedicated for that. And, lines on the floor and everything has its place. But if we do that in the layout, you'll be amazed at how much space trolleys, anything movable, trolleys, racks, pallets, any of that stuff, it just takes up a huge amount of space, because you've not only got the pallet itself, but you also got to get there and move around it and have people interact with it in a meaningful way. And once you've done the layout and you've got everything in place as far as machines, then consider material movements and then consider people. Once again, layer, layer, layer. The more we can layer, the more questions we ask, that are relevant, the better the design. Common sense design principles. If it's easy to clean, people clean it. If it's easy to maintain, people will maintain it. It sounds silly, but it's not. And, things like conveyors, it is so easy now to have them pop up so that someone can just walk along and hose them. Consider AAA rating. Don't have, can I go to the whiteboard? Don't have box section like that. Have it like that. Simple stuff. And in fact, they're moving away from box section in some places and going to folded, because potentially if there's a hole in the weld, you can get contamination, and that can contaminate the factory. So we haven't quite got there yet, but it is a consideration. We don't have to do it, but consider it in the design. Happy people make you more money. People who are happy tend to be expanded awareness. There's a whole bunch of statistics around this. There's so much money potentially that happy people are winners. Happy people will bring you ideas. Happy people will have a laugh. They'll work harder. They're not using so much energy just getting through the day. We can design out through good design by asking the right questions of the operator a lot of their frustrations. We want happy people on the floor. And music. Why not have low-level music playing? If you're out in the garden, doing whatever you're doing, and have a bit of music playing, it just helps the day go a bit further. And I've put music, I've put stereos into factories, and other factories I've said it's a safety concern. It's a choice, but ultimately, to me, the happier the workers, the more optimal the factory, the more money you're going to make. Everybody wins. And I spoke to minimal waste before, so the 5S. So even look at where people are walking, how do they move their hands? It's funny, people who spend a lot of time typing, for example, that are naturally moving their hands around to the 90. What we want to do is we want everything at 45 degrees. We want it nice and accessible. You don't want people doing any of that because that that is not a sustainable motion. Cost and scope. I'm going to give you some general rules around this, and I've gone into factories or come in when they've been down the path of the design and they've ordered $2 or $3 million of machines, and they think they can install it for two or three hundred thousand dollars. And so general kind of numbers: 10% for engineering, 20% for electrical. It depends on how much automation you have, how much you need, steel conduits, all that kind of stuff. It all adds up. But the machine costs can be, 2 times the cost. Sorry, the install of the machine can be 2 times the cost of the machine. So it's just something to keep in the back of your mind. And there are cheats. Like if you're doing panel, for example, there are rates per square meter for flooring, per square meter for lighting, per square meter, and so you can get pretty good estimates, or you know to make informed decisions. And this is where it really helps to have someone on your team who's done it before, who understands the numbers, so you can make informed decisions. And when you're getting machines and buying machines, consider the net present value of that machine. Let's take an air compressor, for example. So over 10 years, 75% of the cost is in electricity. And of course, with the world we're going into, expect electricity costs to be even more. So expect those percentages to change in more of the favour of understanding what the electricity costs are going to be. Timeline. Timeline tells you when to panic. To create space is really, really important. And I spoke before about the juggling balls, and if you get a couple of extras, it fills you up. Inspiration is the thing between the thoughts, not from the thoughts themselves. The timeline gives you that space. So if you're overwhelmed, you're not going to make really, really good decisions. It's just, Henry Ford said, if I'd asked my customers what they wanted, they would have asked for a faster horse. And really what we want is we want step change. We want a Tesla. We want not a hydrogen car. We don't want to just be incrementally better than what we're doing, and we're investing a lot of money. So the timeline tells you when to panic. And so, and look, I've run $20 million projects with no more than a really high level calendar with milestones on it, because it's about the communication and creating tension. So we want tension in the project, not stress. Stress closes the thoughts together and kills innovation. And we want innovation. We want people being open to the possibility rather than closed because they're so full and overwhelmed. Can I go to the one? So if you've got, let's say we've got quality, we'll say this side is time and this side is cost. The more time you have, the less your project will cost. The less time, the more it will cost. Very simple and very true. Give yourself space so you can be innovative. Give yourself space so that you can shop around and organise people. And the other thing in this day and age, it's harder to get good people to work on your projects. Good people are busy. Good people bring in good people. You want to be working with as many good people around you as you can. And that's the 7 stages of factory design, as brief as I can do it. I'm just going to give a few tips on purchasing and installation, just to help you along. But also remember that we're here to help. So reach out to the CCIC, and if we can help you, we'll do our best to do that. It's not only engineers, we've got marketing, we've got quality, we've got R&D. Uh, so utilize the people around you. And it's not just us, there are hubs like us all around the country. So surround yourself with people who can bring you experience, who know what they're talking about. Don't be scared to pay them a little bit extra, because good people bring good people. So you get someone who's really good at what they do, they know other people who are good at what they do. And remember, the engineering cost is that 10%, which drives the 90%. But that cost then determines your ongoing operational cost, which far outshadows the original capital cost. Work with people who have a reputation to uphold. And there's a lot of charlatans and cowboys, and I see it more now than say 5 or 10 years ago. A lot of experiences retired recently, and the industry is really feeling it. So at the moment, we're going through a bit of a shake-up period. It will settle, but at the moment, just be wary of who you do business with. Once again, get experience on your team if you can. You want someone who will service your machine. You know, those old guys who used to work for $50, $30 an hour, whatever it is, just for a bit of fun and a bit extra pocket money. They're really, really hard to find, and there aren't that many out there. We live in a very throwaway kind of society. And so when you're buying a machine, really consider who's going to work with it, who's going to fix it for you, and what ongoing support. And because really, when you're dealing with people, you want to be building relationships, you want to be building partnerships. Advice and no value. If say our yield is our big number, is 60 to 80% of the cost of goods sold, then we want something that's really efficient on yield, for example. By experience, get those people on your team, and support local. And we want people down the road who can come in and help you and talk to you and have a coffee, and this exchange, and this whole idea of win-win-win for everyone. And purchase with servicing in mind. And when you're writing the scopes, write it performance-based. Don't be an expert on how a boiler runs. Just say, I need a boiler that's going to operate and give me this. But if I can say anything, get an engineer on your side. Make teams. So you really don't want any more than 5 reports, and high teams. Learn from my experience. And keep feeding. Like, for me, if I've got 2 guys who do the same kind of role and there's lots of work, I'll feed them both. So I'm not beholden to one of them if he gets busy because the other guy's there, and it creates a bit of, and everyone's getting fed, and that's part of the ongoing. So when you're spending money in the project, what you're doing is you're investing in the ongoing support of your factory and building those relationships, because suddenly you're relevant to them because you're paying them. That's really important. Bureaucracy, my favorite. I farm it out. It does my head in. So, and the other thing too is that people can do it better than me. So why wouldn't I pay them? Because once again, if I deal with bureaucracy, it's going to use 2 or 3 of my balls in the air. And that's really, really expensive when I could be better utilized with my skills. So I farm it out. The other thing too is that people have relationships within it. They know what boxes to tick, but also understand the philosophy behind why they do it. So if you have a look in the food industry, for example, Coles and Woolworths have written books like this thick on what they require, and it goes into the nth detail. But the philosophy is that you want to ratchet forward. So you don't want any raw product going on cooked product. So they don't want anything going downstream. So it's just about ratcheting up. And you don't want cardboard exposed to raw products. If you tear cardboard in sunlight, for example, you'll see the dust float up. So when you understand why they're doing it, not only can you build a contingency for the future, but you don't need to know every rule. And it means that if you're working with the philosophy of it, you can design. It's more manipulable. It's easier to manipulate in order to create a different result that you can then check with the rules. It's just a way of working, but once again, it allows more expansiveness within the questions you can ask of the design.